Hello and welcome to Module 4. So today module named Test Design Techniques, and I think this is the most important topic in software testing basically. And then any foundational level should have these techniques on board. So there are many techniques actually, but the first thing to know when you are designing is software is a system basically, and when you want to test a system, what you want to do with the system, how to approach this system for testing, the first thing is the input, or the best thing to think about is what kind of software you have here. And then when you know the context of your software, then you have to think about the input and the outputs when you enter these inputs, of course. And then how we actually design the test cases and how we actually run the test cases. These four things are quite important when you approach a software to test it. So based on the test documentation standard in IEEE 829, there are three important things to have in any software design, basically in any test design basically. The first thing is the test condition, and then there is a document about that called test design specification. And then you have the test cases, and then there is a document about that in IEEE 829 called test case specification, and then the test procedure or the script, and then this is kind of the test script or manual test script that you have to have. You have formality of test documentation. So what we mean by formal testing and informal testing. A formal testing is kind of systematic testing procedure, that the testing process that has well-controlled documentation, addressing all the details of the test cases, and then how to run these test cases, what are the inputs, what are the outputs, what are the conditions of the system, and so on. During the informal testing, it's kind of there will not be a document basically for testing, and then you have individual tester, but they have no plan, or they have their plan in mind and then they run the test cases. So in reality, in the industry basically, you have a combination between formal and informal. So you cannot be formal all the way, and you cannot run the test cases based on your mind, of course. So you have to have like combination, but it's also depending on the context of the application basically. So for example, for the application with safety critical systems, you have to be formal as much as you can, because this is kind of critical situation, and if you do something mistake or some mistake, then you have to take a lot of responsibility basically. If you test a software for a train, for example, or or software for controlling some like a telepheric or whatever it is, or some software for funfair, so you have to be very careful when you test this kind of software. Or maybe also when you test a software for bank, for example, you have to be very careful, because you will lose a lot of money, maybe you lose life, or so on. So this is very critical, and then you cannot be informal in this way. Now, there are many things around test analysis. So what is a test analysis? The test analysis is the process of looking at something that can be used to derive test information. And then test bases Actually, these are formal definition, but in reality, any company has kind of its local name for these things. But this is how the book said, and then this is mostly used by many industrial partners that we have seen before. So test basis is the base for the test cases that we look at to see what could be tested. So example of test bases. So for example, we look at the system requirement or a technical specification, or maybe you look at the program code, for example, to see how to generate the test cases based on that thing, that test base. So that is a base of our testing, and then we generate test cases based on that base. Test condition is something what we could test, of course. Test condition are documented in IEEE, called test design specifications, something like that. And then when you say that, for example, measure coverage of code decision or branch, the test basis is the code itself, and the list of test condition is the decision outcomes, or you say true false. We have other names, for example, test requirements, sometimes they say, or some people say test inventory or whatever it is, but it is what you understand here. Traceability is to link the test condition back to the source, or sometimes you have a test case but you want to see where this test case is running inside the code, so you trace this test case. Now this is very important. There are many categories for testing, but we have seen some definition in the module before. So we have basically two categories, static and dynamic. So we were speaking about static before, and sometimes we say it's a static testing, and sometimes they say it's a static analysis, whatever it is included in testing area. And we have studied that specifically before. Now we come to dynamic. Dynamic means like we have to test, we have to run the software. So the software code is executed, and then we run the test cases based on this execution. So you have to execute the software to see how these test cases are performed. Now we have a lot of categories here. We will go through most of them. So we have specification based testing, test cases, actually test design techniques, and we have experience based, and we have structural based. Now come back to the dynamic testing techniques. We have specification based testing. Also, we can see in many books they say black box testing and white box testing. So in this case they say black box testing because we look at the software as a black box and we don't care about the internal code structure. We just see the software as a black box. What is the input, what are the outputs, and that's it. And based on that we design the test cases. We see the inputs and outputs and we match them, and we take some test design technique for designing test cases for this kind of software. In fact, to be honest, black box testing has been used before, and still it is used, but this is kind of old name, black box, although it is widely used, because nowadays you cannot say everything is fully black box, because we can say white box also, we can say gray box also, which is combination of white box, black box, and then sometimes the new term is functional, non-functional requirement, functional, non-functional testing. So specification based testing is mostly about functional testing. And then when we say functional testing, it could be kind of black box, or sometimes white box also is functional. Also, we have non-functional testing based on specification when we are dealing with what the system does, or how well that system does that thing. So that is the non-functional testing. So during the functional testing, we are focusing on the features of the system and what it does, and then what we get at the output. So for example, imagine that we want to test a system based on for its performance. So performance here is something non-functional. So how to measure the performance? What is the performance based on the output? So that is something that we can negotiate on, and then we can speak about it. But basically, that is something that we are speaking about in non-functional testing for the software, for the whole software. So we can say that the performance of this system is good or it's not good, and then we can say that the reliability of this system. So there are many non-functional requirements that we can test, and then we can say that these non-functional requirements are good or bad, or good to some extent, and so on. So now we have many techniques for specification based testing. So we are going to, for example, equivalence partitioning and boundary value analysis, and when we go for decision table, and then state transition, use case testing, and so on. So basically, these techniques are classic in software testing, basically. And then you can see later on that, and also in the new research area that of software testing, that people are combining these techniques together to create new techniques. But these are the basic techniques that we can look for based on this specification. Now, equivalence partitioning is probably the classic, the basic test design technique that used quite a lot before, and still it is very useful. So in equivalence partitioning, we look at the inputs and outputs, for example, and then we can partition. So the input of the software has kind of pattern, and then we can group these inputs based on these patterns, and then based on that we can partition and group the inputs, and then we take sample from each input partition, and then that will be the equivalence partitioning. So we partition the software, and then we design the test cases by designing at least one test case to examine the input data to the software, or the system input data, by taking a representative of that class. Now, as an example here, if we have a software or we have a program, and then this program will produce a triangle based on the input that we provide, and then we give three input A, B, and C, and then we see that what is the kind of this triangle. So basically the software will tell you whether the triangle is equilateral, or is it isosceles, or it's scalar, and you can find the graph of each one of them here. So you can find the conditions here also. So basically you have partitions. You can partition these inputs. So you can have different kind of partition. It depends on which kind of input you are providing and then what you are searching for. So for example, here we are partitioning the input based on valid triangle and invalid triangle. Valid triangle, we say that, okay, this kind of triangle is basically one kind of the three kind that we set for the sorting of the triangle, or it is not any kind of these things. So basically, when we go for the equivalence class for valid triangle, we try these conditions and then we have the test cases. So basically we have 8 test cases, then these are just random number we pick to meet that test case. So we pick a number for A and B in which when we collect them, they will be greater than C. And then if we meet that, it means that we have this kind of scaling or isosceles or equilibrium. So this is kind of dividing them. And then we can design test cases for invalid triangle, for example, and we have set of inputs here, and they can, for example, we can enter -1 and see what's going on for invalid input, for example. Or you can say that A equals to 0 or B equals to 0 and so on. Another kind of test design technique is boundary value analysis. Also, this test design technique is simple, but it is really nice because we can identify the test cases easily by knowing the boundaries. So if, for example, your input is swirling around some boundary, you can say that, okay, if my input is between 0 and, for example, 5, it means like we have a range. And then based on this graph that we provide, we can say that, okay, we have the minimum and we have the maximum, and then we just choose a value just below the lower boundary value, the lower boundary value itself, and then the value just above the lower boundary value, and then the value just above the upper boundary value, the upper boundary value itself, and then value just above the upper boundary value. Now, when we approach this, we can be sure that we are covering the boundaries. And why we do that? Basically, there are a lot of evidence in the past research proving that faults are basically on the boundaries. So imagine that you are writing a code and then you say that, okay, there is an if condition, and then you say that if A greater than or equal to 5. Then you basically forget to put equal. Then A is greater than 5 here, but in the original specification of the software, it should meet greater than or equal 5. Here, if 5 is the maximum value here, so you choose a value above the maximum value, which is 5, and then you pass, which is fine. That test case will pass. But then you choose 5 itself, and you will see that, okay, my test case will fail because you forgot to put equal here. And that is the one case of boundary value analysis. We have another kind of test design technique called cause and effect analysis via decision table. So here, if you have a system with such an input that you can map the input and output based on cause and effect, and you can put them on a decision table, so it means you are in a good way to design to use this cause and effect analysis for testing. So for example here, if you are going to test a database, so this database will take two input in command, which is display or print, or combination, of course. Now D will refer to display and P refer to print. And then you have an index from 0 to 9, which is like 10 value index. Now you have, if the first letter is not D or P, then the system display invalid command anyway. So if the index number is not between 0 and 9, then the system have to say that invalid index name. And then if everything is okay, the system will give a good number or valid index, or it will print or display the value in that index. Now you can see that we have here in the table, in this decision table, you say that when you press D, that is a cause. And what is the effect? The effect is display. So you have a set of input, which are the cause, and then you have a set of output, which are the effect. Now you have 4 test cases, for example. If the D is true and the value is between 0 and 9, then you come back to the decision, to the action or the effect, and then it will display. So you have this test case now. Based on this table, you go to the software and run it. And also, if the D is false, but the P, which is the print, is true, it means that you have to print, the software will print, but if the index is between 0 and 9, which is true here in test number 2, and then the output will be indexed, the value of that index will be printed. Now, if the character is not D or P, never mind. So that's why this cell is empty. It means like I don't care. It's don't care, because if both of them are fail, even if the index value is between 0 and 9, or it is not between 0 and 9, so if it is true or false, it means nothing, because both D and P are not there, so it is valid command. So if the index is false, doesn't matter whether the D or P are true or false, because the index number is not there, and then the output is invalid index number. So this is kind of decision table here. You can design the test cases based on that.